How's it going, guys? Today we're going to be going over a problem called PathSum. This is a common interview question from Amazon. I apologize I haven't been uploading the past couple days. Unfortunately, I've been feeling a little bit under the weather. But anyway, so the problem description says, given a binary tree and a sum, determine if the tree has a root to leaf path such that adding up all the values along the path equals the given sum. Note, a leaf is a node with no children. So as an example here, if we're given the sum 22, and then this is our tree, we know that 5 plus 4 plus 11 plus 2 gives us the sum 22 that we're looking for, and we also end our path on a leaf node here. So because of that, we would return true in this case. And again, they're just saying return true because there is a path that exists from root to leaf where the sum is 22. Cool. So almost always in tree problems, you want to use recursion. And so what we can actually do here is we can take the sum and we can kind of break this into subproblems. So at first we want to ask the big question from the top of the tree, which is from this root, can we find a sum of 22 going all the way down to the leaf level? So what we can actually ask at every recursive call is we can take away whatever the value of the root or whatever node we're currently on from the sum we're looking for, and then pass it down to its children. So we could say here, we could break it down from, okay, is there a path from the top of the tree to the bottom of the tree where the sum is 22? We can break that down into 22 minus 5, so 17. And then we can start the question again from these two children. So now we can have a question that says, okay, starting from here, 4, is there a sum of 17? And then starting from 8, is there a sum of 17? And we can kind of just recursively make these calls every time subtracting whatever the sum is of the given node that we're on from the sum, or sorry, the value of that node from the sum. And just if we get to 0, then we know that we've found a path as long as the node we're on, if its left and right children are null. So hopefully that made sense. If it doesn't, we can kind of go through it a little bit more, but let's start coding the solution. So if our root is null, which is a lot of times your base case in recursive calls with trees, but if our root is null, meaning we've basically reached something down here, right? So below 7, 2, and 1. If these children, right, which are all null, if we've gotten here, that means we haven't found a path. So we can just return false because we haven't found a path that sums to the sum that we're given. Otherwise, now we want to check the case where we've actually found a path. So else if we said if it's a leaf node, so if the root's right child is null and root dot right. I always like to put left first, so let's do that. So if the left child's null and the right child is null and the root dot val, which is the value of the node that we're currently on, minus, sorry, I'm doing this backwards, if the sum minus the node's value that we're currently on is 0, then we know that we found a valid path, so we can return true. Otherwise, we said we want to pass these recursive calls down to the children by subtracting the root's value or the node's value that we're on currently from the sum that we're looking for, and then ask the same question. So we can just return whether or not these two recursive calls that we're going to pass to the children return true. So either of those return true, then we found a path. So we can say as path sum, see these are our recursive calls, we'll pass root.left and we'll pass sum minus root.val. So either that finds a path in the left subtree that we're on, or we have to check the right subtree as well. So we'll say has path sum root.right, and same thing, sum minus root.val. So again, as a quick overview, we're going to make recursive calls and kind of break down the big problem into smaller subproblems by subtracting whatever the current node's value is from the sum that we're looking for. So initially our call will be from the root asking for a sum of 22, and then we'll ask, okay, we haven't found a path yet, so we'll ask the children in recursive calls. So we'll subtract 5 from 22, we'll have 17, and we'll just say, hey, is there a path all the way down to the leaf nodes that has a sum of 17? And we'll ask that for the left child and the right child, so the left subtree and the right subtree. So if we get all the way down and the root is null, meaning we've gone through all the leaves basically, we're going to return false. Otherwise, if we have found a leaf, and the sum is currently 0, then we can return true. Otherwise, we just want to traverse the left and right subtree and return true if either of them actually have a path that adds to the sum. Awesome. And that works. And that's how you solve path sum. This is asked by Amazon. Make sure you guys know how to do this. If this was helpful, be sure to subscribe and leave a thumbs up. I try and release a video every day so you guys can see a new tech interview that's asked by these large tech companies. Good luck on all your interviews, and I'll see you guys next time.